All right, I've now started the recording and I'm saving it locally. All right. Okay, so in the next 18 minutes, we're going to get started on the second introductory notebook, and that's going to be a notebook taking us through some of the basic commands in the R language. And the reason that we're doing this is because as we get farther on in the workshop, we're going to process some RNA sequencing data. And after processing it into a form that's analyzable, we're going to use the R language to do some data analysis at the very end. So in order to kind of understand what we're doing when we do data analysis, it's nice to understand just some of the basic commands in R, reading in, writing out files, so on and so forth. So that notebook is, you can see here on the left-hand side in my file tree, it's called R Intro JN 0622. Please double click that notebook and open it up. I'm also going to put this in the chat. So when you open this notebook, you should see up in the top right-hand corner different kernel. So yesterday I introduced the idea of a kernel in a Python or in a Jupyter notebook. And the kernel, I said, is kind of the background installation and language that the notebook is set up to run. So here we have a new kernel called R conda-env GL4U-R. And down here in the left-hand corner, you should see that name again, and it should say idle. So has anyone not been able to open this notebook or does not see the correct kernel in the top right or doesn't see idle in the bottom left? All right, great. So this notebook again has a table of contents. We're going to go through a short introduction to the R language in general, and then just some basic programming commands and dealing with loading and viewing a data file. And then we're going to work on a data frame, which is like a matrix of data held in R. We're going to do some basic manipulations to a data frame because that's something we do a lot with RNA sequencing data. And then we're going to show how to export a data set after you've done some analysis with it. And finally, kind of a fun part, which is to do some visualization of the data. So again, this is an interactive table of contents. You can always come back and click on one of these hyperlinks to take you to the part of the notebook that you're interested in. Okay, so what is R? R, as I mentioned before, is a programming language, one of many, but it's designed specifically for statistical analysis and computing. And it's very popular in bioinformatics because a lot of bioinformatics and data analysis has to do with statistics and mathematics. So R has many libraries, which here I'm using library to mean a collection of code that's set up to do a certain job, to run a certain analysis. And so there are many libraries that are designed specifically for bioinformatic analysis and statistical analysis and for making nice visualizations to showcase your data. So this Jupyter notebook, as we noted, is running an R kernel. And that means that each cell is designed to interpret and run commands that are written in the R language. A Jupyter notebook cannot run both a Python kernel and an R kernel at the same time. So let's see here. I'm going to set up a poll question. Which language did we use when we were running the Unix commands in the previous notebook? Let's see if I can do this correctly. Are you guys seeing a poll? This is the first time I've done this. Oh, good. People are answering. It must mean it's working. So which language were we using in the previous notebook, the Unix intro notebook that Amanda just finished taking us through?
For me, I can't type anything. Maybe it's set to have options instead of free text or something.
Okay.
Yeah,
How,
I have the
how
same
have three
idea.
people answered? That's interesting. All right, let me try this again. Thank you for your patience. Okay, how about that? Do you guys have a box for answers now?
Yep.
Better now, yeah.
Okay, perfect. Yeah, so just waiting on a few more people. What was the language that we were using when we were running Unix commands in the previous notebook? If you don't know, feel free to say that and we'll go over it together. Still have a few people who haven't answered, so I'll wait a few more seconds. All right. Okay, so I'm not able to actually see the answers here. I
You can
just,
put the boxes that says show full results.
yeah, I have share with attendees, poll
Yeah,
results or individual results.
click both of them and just make sure you're on a web browser that isn't the one that's being used.
Right. Okay. Got it. Okay, great. Thank you. Okay. So thank you. So thank you everyone who answered. So I see a lot of Python, which is correct. We were running a Python notebook, and then we were adding the exclamation point or the percentage sign so that the Python cells could interpret the commands into Unix or Bash. And I see someone said the best language there is Bash. Very good. So yeah, so that was a Python conda kernel or a Python notebook kernel. So if that doesn't make sense to anyone, please feel free to shout out or put in the chat and we can go over that. But so far we've used a notebook with a Python kernel. Now we're using a notebook with an R kernel. So in R, kind of unlike the Unix notebook, in the Unix notebook, we were accessing the base installation of Unix. All of the commands are just there. They're available for us. We can call on any of them. Well, in R, there is a base R installation, but there are so many different libraries, collections of code that people have written and submitted because R is an open source language, that if we were to load all possible libraries in with the base R installation, it would overwhelm the system. It would be too large. And we don't need all of those libraries anyway. We only need the ones that do the work that we're interested in. So, right, as I said before, an R library or package is a collection of functions, compiled code, and sometimes it comes with example or sample data. And there are some R packages that are installed automatically with the base R installation, but hundreds are not. So if you want to use one of the packages that doesn't come with the base R installation, you have to install it yourself using the function called install.packages. So this is our first function in R, and I want you to note a couple of things here. So the syntax for a function in R is you have the name of the function, which here is install.packages. So that's the name of the function. It has a dot in the middle, and that's just part of the name. And then each function ends with an open close parentheses because you often need to pass things into the function, like the name of the package that you want to install, for example, is something that you would pass in to this function here, and you would put it inside the parentheses so that the function knows to interpret that as an input to itself. So we can install a new package using the install packages function. That just installs it. We have access to it, but we can't actually run it yet because it hasn't been loaded into our current running instance. So in order to actually load it so we can use it, we would use another function called library. And that also ends in an open close parentheses because that's how the syntax for functions in R works. So for example, this is something that we're going to need to do later on when we want to do some bioinformatics analysis. We're going to need to install the package called BioCManager, which is kind of an overarching package management library. So the way that we would install that is to run this command in R, install.packages, parentheses, then we pass in the name of the package that we're trying to install, which here is BioCManager. We wrap this name in quotation marks so that R will interpret it not as a name or a variable, but as a string, so just a list of letters. And I'll go over strings more later on, but just know that you need to wrap the name of the package in quotation marks when you pass it to your install function. So there are multiple packages that we're going to need to use that we can access now that we've installed the BioCManager package. And that includes this package called DESeq2. So this is a very common package used for differential gene expression analysis. So RNA sequencing measures gene expression. We want to compare gene expression between two groups. And so we'll have to use a statistical library to do that statistical comparison between two groups. So that package and others, we then will use an install function that comes with the BioCManager package, and then we'll load it in using the library function. So here is some special syntax to access the BioCManager package that we just installed. We need two colons because that's the syntax demanded by this package. Then we pass in the install function and the name of the library that we want to install. So that here is DESeq2. And then on the next line, we can run a command called library DESeq2. And that will load everything that we need from DESeq2 into our current running instance of R. So we are not actually running any of these commands right now. I've just put them here into the markdown cell so that we can just see the syntax and become familiar with it, because this is something that we're going to do later. In a minute, we will actually run some R commands. But before we get on to the next part, which is defining locations and assigning variables in R, I want to know, are there any questions about what I've just gone over? Installing and loading packages or libraries in R, or any of this new syntax? Okay, great. So the same way that we can do this in Unix, we can see where we are in our directory structure and change directories in R. So there's a function getWD that stands for get working directory. You don't necessarily need to put anything in the parentheses. This function can work with empty parentheses and it'll just tell you what's your current working directory. And it's similar, again, to the pwd command that we just learned about in Unix. A parallel or similar function is the setwd function. Stands for set working directory, and it allows you to change your current working directory, and it's similar to the cd command we just learned about in Unix. So I'll talk a little bit more about setwd and what you need to put into the parentheses to make that function work in just a moment. But first, let's go ahead and run our first R command, which is getwd in the next cell and print out current working directory. So I'm going to set another poll here, and you guys can tell me where you are in the cluster. All right, so the poll is now open. If you run getwd in this cell, where are you located? All right, I see several people have not yet answered the question. Is anyone having trouble, anyone getting an error or not able to run this cell for some reason? You should all be able to run this cell using the run button. Just run getwd and get an output, which should tell you where you're located within the cluster, and then you can put that into the pool. All right. See, we're out of time, so I'm going to go ahead and close this poll. Great. Some person named Jovian's home directory. Good. So everyone is in their home directory. Home, Jovian. Very good. If anyone was not able to run this command, please let me know in the chat. And I'm going to stop recording now so that we can go on our lunch break.